IUPAC system and the naming structure I've shown you in my introductory video. When you're naming a simple alkane, whether you're looking at line structure, condensed structure, or complete structural formula, the rules are the same. Recall that we broke every name into 4 pieces. We had a prefix, a first name, a last name, and a suffix. Given that we have no branches, no substituents or functional groups, a straight chain alkane will only have 2 parts to the name. The first name, which is the number of carbons, and the last name, which has to do with the type of chain. Let's start with this molecule. For the parent chain, all I have is one single carbon. Since the prefix for 1 is meth, that's the first name, and since I have no double bonds between this carbon and any other carbon, I have an alkane which gives me ane. Putting the name together, this molecule is methane. Now what if you have a molecule that looks like this? CH3, CH3. First I count my carbons, and I see that I have 2, giving me a first name of F, and then I can draw this out or visualize the structure to see that there are only single bonds giving me ane. If I put this name together, I get ethane for the molecule. Now let's look at a larger molecule. As your molecules get larger and more complex, you want to take a few steps to keep track of what's going on. The first thing I like to do is highlight my parent chain and then number it. In this case, because there is nothing coming off the molecule, I can number from either direction, and I get a total of 5 atoms. The prefix for 5 gives me a first name of pent. A lack of pi bonds gives me a last name of ane, which gives me the complete name for this molecule, pentane. Recall that sp3 bonds have a bond angle of 109.5. This means if your molecule is drawn out more realistically, it'll actually look something like this. Don't let the angles between the carbons fool you. If you can place your highlighter on the first carbon and then trace it all the way to the end of the chain without having to lift in the middle, this tells you that you have one continuous parent chain. Once again, I can number from either direction, and now apply the puzzle pieces. For the first name, I have 6 carbons, which gives me a first name of hex. I only have single bonds, which gives me ane, and that means this molecule is hexane. A faster and simpler way to draw this molecule is by using line structure. I'm going to follow the exact shape of what I have above to represent the 6 carbons. Recognize that every end and every angle represents another carbon atom, and all the hydrogens are invisible and not that important to naming. I approach a molecule in a line structure in the same manner, where I first highlight the parent chain, and then assign numbers to help with the naming. Once again, recognize that we have 6 carbons and therefore the molecule hexane. Since carbon-to-carbon single bonds have the ability to rotate, you can see this molecule represented in a nonlinear manner. Looking at the structure I drew here, I still have only 6 carbons and therefore only hexane. So no matter how the molecule is presented to you, don't let that fool you. Let's look at one last simple example before moving on to branched alkanes, and we'll use this structure as our example. The first thing I want to do is highlight my parent chain. Since I don't have to lift the highlighter from beginning to end, that tells me this is one continuous chain. When I number the chain, I get a total of 10, which gives me a first name of dec. Since I only have single bonds, that gives me a last name of ane, and this gives me decane. If you feel that I went too fast, go back to my first video where I show you how to break up the name and what prefixes to use. If you feel comfortable till here, let's move on to branched alkanes. Are you struggling with organic chemistry? Are you looking for information to guide you through the course and help you succeed? If so, download my ebook, 10 Secrets